So when we go from an entire radical, which is what I have on the left of this big long line in the middle of the screen, the fourth root of 1200, when we go from an entire radical to a mixed radical in simplest form, the idea is we want to extract factors whose root can be taken as an exact value. So for example, if I have the fourth root, I'm looking for something that if I took the fourth root of, I would get exactly some number. And that thing that I can take the fourth root of is 2 to the 4, which happens to be 16, but it's not relevant. The fourth root of 2 to the 4 is 2. The idea here is that index, we're going to call this 4 that's by the square root sign, and my computer's just locked up, so you have to give me a second. That 4 that is by the root sign matches the 4 that's a power of 2. And those two things basically undo each other. Finally. So I won't use the highlighter. These two things undo each other. The idea here is that since you have 4 2's underneath the fourth root, you can combine those 4 2's into 2 raised to the 4. And what 2 raised to the 4 is, if you wanted to figure it out, is it's 16. And then we have times 3 times 5 times 5. But then I can write this as the fourth root of 16 times the fourth root of, I'm thinking this is 75. 3 times 5 times 5. And the fourth root of 16 is 2. Why is the fourth root of 16 2? Because 16 is 2 to the 4. So we kind of go in circles on this. The bottom line is, if you see 4 2's under a fourth root, then you can write it as a single 4 outside, a single 2 outside of the fourth root. And we can do the opposite too as well, right? If I have 6 multiplied by the cube root of 20, when I put that 6 underneath the cube root sign, I have to cube it, because the cube root of 6 cubed is 6. And then I can figure out that 6 times 6 times 6 times 20 apparently is 4,320. And that's really what we learned yesterday. And it's just an extension of what you already knew about square roots, but we took it to the next level with cube roots and fourth roots and fifth roots and whatever root we want to. The other thing to keep in mind is you have to talk about restrictions of variables. Variables are not allowed to be negative if them being negative resulted in an even root of the radicand. Okay? Any questions you'd like me to go over? Go ahead, Kendra. 10D. Okay. So we have to simplify this, and all of a sudden it got quite complicated. It went away from numbers, and now we have fractions. And I'm going to rewrite this a little bit different first, though. I'm going to write this as w over 5 times the cube root of negative 64. And then I'm going to write plus 1/5 times the cube root of 512 w cubed minus 2/5 times the square root. We've got to be careful here. Mixing up cube roots and square roots, the square root of 50w minus 4 root square root 2w. So I'll just make sure that I've written that down correctly. And it is. So, Kendra, you asked about this question. So when I take a look at this, would you be personally fine with breaking root 50w into 25 and root 2w? Probably. And a lot of people would be. And if you're fine with that, then you will be fine with what I do instead. Okay, but you can take these shortcuts if you like. What we want to do with all of these, to see what can come out, is to take everything under the radical and factor it into prime factors. So 50 is 5 times 10, which is 5 times 2 times 5. I didn't leave myself enough room, maybe. I can squeak it in there. Nope. So this is going to be rewritten as 5 times 2 times 5 times w. This last one, there's nothing I can do with 2w. I can't factor it anymore. Over here, I need to do the same thing to negative 64, and I'm trying to decide when I will reveal this to you. Maybe I will reveal it to you right now. If you're taking an odd root of a negative thing, that negative can go outside. And the reason for that, I'm going to take a detour away from this question just for a second, but if I had the cube root of, say, negative, it doesn't matter, 18. I can write that, everybody, as the cube root of negative 1 multiplied by the cube root of 18. Because negative 1 and 18 multiply to give negative 18. What is the cube root of negative 1 asking us to find? The cube root of negative 1 is asking us to determine, please put your phone away, is asking us to determine the number that if you were to cube gives you negative 1. So I know you get that, but in terms of everybody else, I want to make sure you get that. The cube root of 27 is equal to 3 because 3 cubed is 27. The cube root of 8 is equal to 2 because 2 cubed is 8. So the cube root of 8 is saying, what do you cube to get 8? 2. The cube root of negative 1 is saying, what do you cube to get negative 1? And the answer is negative 1. So then I have cube root of 18. So when I'm looking at this over here where I have the cube root of negative 64, part of me wanted to just make the negative appear in front of the w over 5. I'm going to do this just in steps, though. I'm going to put negative 1 there, and then I'm going to take 64 and I'm going to tear it apart into as many small numbers as I can, and it turns out that it will be 2 times 2 times 2 times 2 times 2 times, I believe, 2. I think there are going to be 6 2's there. And then I have, and I didn't really leave myself enough room. This is the advantage, Kendra, of us writing 2 to the 6. Then we don't have to space it out. So I'm going to squeeze this in here. 1/5 cube root. Oh man, 512? I think that's 8 2's. Is it 9? 2 to the 9. Can I get somebody to confirm? Well, everybody, play along here. 2 to the 9 is 512. It is. I better check here. Is 64 2 to the 6? 128. 2. Oh, right. I missed one. 256. So I'm going to actually write this out. If you don't have to write this out, then that's great, but some people may need to. I'm going to have cube root of 2, 2, 2, 2, 2, 2, 2, 2, 2. I'm not going to put brackets. We said 9? Okay. And then I have w, w, w. I see w cubed. I would have just written the w over here. But I'm doing this in steps for everybody. So now, if we look at the first term, I have a group of 3 2's under a cube root and another group of 3 2's under the cube root. I can take both of those 2's outside now, and then I have w over 5 cube root. Well, you know what? That's all I have, isn't it? Because what I'm going to do at the same time is I'm going to put a negative there. Everything was extracted. And you know what you could have done is you could have just said the cube root of negative 64 is negative 4. Negative 4 cubed is 64. And that's what we pulled out. The next one, I'm going to take out a 2, a 2, a 2, a W, again, everything goes away. In other words, that 512W cubed was a perfect cube. So now I'm left with 1/5, and I'm taking out a 2. I'm taking out another 2, I'm taking out another 2, and I'm taking out a W. And what do I have left? The cube root of 1, which is just 1. Don't forget, and I almost did, about that 1/5, right? Over here, what can I do? I can take out this 5 because it appears twice under a square root. So I'm going to have minus the 5 I take out times the 2/5. And I hope it's understood here, but Kendra, you're the one who asked about this question. The order in which I write these two things doesn't matter. I could put the 2/5, then the 5, then the root. I'm left with root 2W, which is really nice because that's what I happen to have over here. So this is an exercise in your algebra skills, this question. Let's start packing this stuff together again. This is negative 4/5 W. I'm just multiplying across the top, and I'm multiplying across the bottom. Plus, I have 2 times 2 is 4 times 2 is 8/5 W. Here I have negative 2 root 2W, because 5 times 2 over 5. Well, if you take 5 times 2 and then you divide it by 5, the 5 will go away. And then I have minus 4 root 2W. If I were you, I would think of these. I almost always like to write fractions the way I have here with the negative 4/5 W plus 8/5 W. But it would serve us better to think of it this way. Then we have a common denominator. And this would give us negative 4W plus 8W over 5 minus these we can combine into 6 root 2W. Still good, Kendra? Okay. And then finally we can just clean this up and write 4W over 5 minus 6 root 2W. Is that okay? W, of course, cannot be negative. I don't know how that plays into this question, if we really care or not. It does actually say identify the restrictions, so we would need to say that W must be greater than or equal to 0. Good. Now, just to go back to this question for a second, I'm going to leave all this here in case we need to refer to it and just clone the page and start again. That was really messy. Now I have a limited space here. You could probably write smaller on paper and get it on one line, but I'm not so concerned about this. Well, you know what? I kind of am. It's better if you can, I'll do it with the 2's. What did we say? We said cube root of negative 1, right? Would you agree negative 1 is negative 1 cubed? So there are 3 negative 1's under there, aren't there? There's a negative 1 times a negative 1 times a negative 1. Because negative 1 cubed is negative 1. And then, that's cleaner. I know I said to you yesterday some of you will not be able to handle this, but sometimes you need to. 2 to the 6. I don't want to write 6 2's. 2 to the 6. And then the next step would be to say that you're taking groups of 3 out, right? So how many groups of 3 are there in 6 2's? There's 2 of them. So what you can do is take out that negative 1, put it wherever you like, and then you can just put 2 times 2, because this is 6 2's. We took them out 3 at a time. And you could certainly do that for the 512. It would just make your life a little easier. Other questions? Yeah.
Number 4, the third one.
Okay. So we would like to take 1 over 2a multiplied by the cube root of 7a, and write it as an entire radical. And that means that everything outside of the radical symbol that's a cube root has to go inside. Remember, we can actually, Ariana, think of this as kind of something that maybe already happened. What if that was already inside and somebody removed it? If it was already inside and then it was removed and written as a single 1 over 2a outside, then before it was removed, we would have had to have 3 of them inside. So what we end up with here is the cube root of 1 over 2a times 1 over 2a times 1 over 2a times 7a. And look at how I wrote that 7a in relation to the other things. It's up top, right? Because 7a is 7a over 1, and everything else is a fraction. So I want things to line up fraction-wise. You get my drift there? Okay. Could I have just written 1 over 2a quantity cubed? Certainly. Now what we're going to do is we're going to simplify this. This is the cube root, and when I'm multiplying fractions, I can always multiply across the top. So 1 times 1 times 1 times 7a is 7a. And multiply across the bottom. 2a times 2a times 2a times 1 is 8a cubed. I mean, I think you know this, and I think everybody should know it, but 2a times 2a times 2a you're multiplying 2a by 2a by 2a, but 2a is 2 times a. So you're multiplying 6 things. It doesn't matter the order in which you multiply them, right? You can go 2 times 2 times 2 times a times a times a. So you get 8a cubed. Now what we have is we have a to the power of 1 on the top. And how many of you remember that when you divide common bases, you subtract the exponents? I guess we got to talk about this sooner or later. I wouldn't do that in this case. I would cancel an a. The result will be the same. But what I'm saying is that underneath the cube root sign, I have 7a, and then I have 8, and then I have a cubed. So I'm just going to cancel one of those a's, and I'm going to get 7 over 8a squared. So the answer is the cube root of 7 over 8a squared. Now, I just said I wouldn't have subtracted the exponents, but could you have subtracted the exponents? Could you have said that I'm going to take a to the 1 divided by a cubed, which will give me a to the 1 minus 3? Yes. 1 minus 3 is negative 2, so you get a to the negative 2. But now we have to think of negative exponents, and a to the negative 2 is 1 over a to the positive 2, which is why I have a squared on the bottom. Okay? Are you okay with that? Okay. I have to address the variable here, though, and I don't know if we need to or not. We do. Well, that's weird. Okay. I don't know. Come on, man. What's going on here? Okay. In a case like this, where you have a cube root, are you allowed to take the cube root of a negative? Yes. So you might think there's no restriction here, but there is a restriction in this one. The restriction is a cannot be 0. And the reason a cannot be 0 has nothing to do with the cube root. It has to do with the fact that we're dividing by a. And you cannot divide by 0. Now, if this were an even exponent, like 8, then you would start by saying, well, a can't be negative, right? Because then you would take the square root of a negative, and then you would say that means that a must be greater than or equal to 0, but then you would see this a in the denominator and go, oh, you know what? No, a can't even be equal to 0. A must be positive. And I'm showing this to you not because it's a big deal in this unit, but it's going to become a bigger deal as we go deeper and deeper into high school math, of which you're halfway through high school math right now. And we're kind of halfway there. We've got a long way to go. Other questions? All right, then we are going to move on and look today at multiplying radicals. This lesson is 20.5.2, and in your textbook it's called Multiplying and Dividing Radical Expressions, but we are going to be doing this in 3 days, I think. There's 3 parts to this. If I tried to teach you everything in this one section in one day, our brains would explode. So what are we doing today? We're multiplying radical expressions and simplifying the result. And then we're also going to be dividing, I don't know if we'll get to this today or not, but dividing monomial radical expressions and rationalizing the denominator. And you know what? I don't think we're going to be doing that. I just want to look quickly here. We are not doing that. All we are doing is multiplying the radicals today. Even including this next section would be too much to get through in one lesson. So we're going to be multiplying radical expressions. So there's a rule we use here, and I just want to convince you that the rule works, and then we'll get to applying it. When you're multiplying radicals, coefficients can be multiplied with coefficients. Radicands can be multiplied with radicands. That's what this means. Multiply the coefficients, and then multiply the radicands. So you can only multiply radicals as well if they have the same index. What does all this mean? Well, if I look at these two radicals, 5 cube root 6, I'm going to multiply it by 3 cube root 7. The 5 and the 3 are coefficients. That's what a coefficient means. It's a number that's being multiplied by the radical. On the other hand, the 6 and the 7 are radicands. The 3's are the index. And that's a word that you learn about in Math 10, but I'm just reminding you, if I gave you something that had 4th roots multiplied by cube roots, you can't do anything with it. Not yet, anyway. Okay? So according to this, 5 cube root 6 times 3 cube root 7 should give us 15 cube root 42, because 5 times 3, the coefficient times the coefficient is 15, and when I multiply the radicands, I get 42. So these two things should be equal. Now, I don't want to get bogged down into a whole bunch of calculator work, but you do have on your graphing calculator a cube root function. It's kind of buried a little bit. If I want to take 5 times the cube root of 6, I go 5, then I hit the math key, and I scroll down to option 4 on my calculator. This looks horrible. That's not how you would write 5 cube root of something. It almost looks like 5 is raised to the 3, doesn't it? But that's what this is. And in fact, you know what? I wish I was king of everything and I would get people to change how this even prints. Because I think that 3 should be smaller and buried inside of that little radical symbol. I think it should be like this. I think it should be obvious that that 3 is not an exponent but an index. Anyway, I'm not king, so we're just going to have to live with it. Now I can enter 6, and I have to close the brackets on that, what we call an argument, on the thing we're cube rooting. And then I'm going to multiply that by 3, multiplied by the cube root of 7. So 5 cube root 6 multiplied by 3 cube root 7 is 52.1403. And it's an irrational number, so it goes on and on. We can't be confident about all the decimals, but that's what it's approximately equal to. If I figure out what 15 times the cube root of 42 is, it should come as no great shock to you that it's the same number. And all I'm doing with you is demonstrating to you that this rule is true. It works. Okay? All right. Oh, I even had it there. Look at that. So let's multiply and simplify the products. Now the first thing to note is, why did I write it this way? I could have written 2 root 5 times 5 root 6. I could have written 2 root 5 times 5 root 6. I could put brackets around this or that or both or neither. It doesn't matter. Don't get bogged down in where the brackets are because I'm multiplying. And I want to explain to you briefly that this means 2 times root 5 times 5 times root 6. And as I've already told you today, the order in which you multiply things doesn't matter. So multiply the 2 by the 5 first and get 10. And root 5 times root 6 is root 30. And we're done. Very, very simple question. B, negative 8 root 15 times 3 root 10. Well, that seems pretty easy. Negative 8 times 3 is negative 24. And root 15 times root 10 is root 150 because 15 times 10 is 150. So we get this. And we're not done. We were done here because root 30 cannot be simplified. There's no perfect square that divides into 30. Or if you were to write root 30 or think about it and say, let's see, root 30 is 2 times 3 times 5. I think that's right. I don't see a pair of numbers that are identical, so I can't do anything with it. But this can be simplified. By the way, I'm just going to point something out to you that might be helpful for some of you. I know that it can be simplified because if you look up here, please, for a second, 15 has a factor of 5, and so does 10 have a factor of 5. So when we put them together, there's going to be a pair of 5s in there. If you want, you can write this as root 25 root 6. This becomes negative 24 times 5 root 6. And we can multiply the 24 and the 5 to get negative, help, 120. Root 6. I said if you want, you could do that. I don't mean if you wanted to, you could just say, I'm not going to finish the question. What I meant was you could also instead take the 150 and tear it down. Let's see, 15 times 10. 15 is 3 times 5. 10 is 2 times 5. So this 5 and this 5 join forces together with the negative 24 as a single 5 outside. And this is a 2 and a 3 left over, and you still get negative 120 root 6. I'm just curious. I mean, I'm sure everybody understands how to do the method on the right. But how many of you see, by a show of hands or a nod of the head, that the one on the left can be quicker with square roots anyway? Okay? You have to balance accuracy with speed. Meaning, if this is the only way you know how to do it, it might slow you down enough to make you not as successful. So the correct answer is negative 120 root 6. Let's take a look at the next one. Holy smokes. 2x root 5x to the 5 times 4 root 75x cubed. Well, I'm going to take the 2x and multiply by the 4, and I'm going to take the root 5x to the 5 and multiply by root 75x cubed. I haven't really done anything here yet, everybody. I'm just pointing out I'm going to multiply the coefficients and I'm going to multiply the radicals. So 2x times 4 is 8x. And then I'm going to have a single root, and I'm going to have 5 times 75, which is, I believe, 375. Thank you. X to the 4. Nope. X to the 8. Because I have x to the 5 times x to the 3, I'm adding the exponents. Again, I don't want to spend a whole bunch of time reviewing exponent laws, but x to the 3 times x to the 5, you add the exponents because x to the 3 is 3x's multiplied together, times x to the 5 is 5x's multiplied together. So how do we abbreviate that? Well, we write x to the 8. Now, can we simplify this? Yes. I start to struggle now as a teacher at this point in this lesson or unit with, do I really want to write do I really want to write 8x's? Think about this for a second. You're taking the square root. You're taking the square root of x to the 8. It's going to become x to the 4. It's going to become half of that exponent, or of 8. So we're going to have 8x. We can write x to the 4 outside, because if I put x to the 4 inside, I'd have to put it twice, which is x to the 8. If you want to think of it this way, great. Pull out an x and an x, pull out an x and an x, an x and an x and an x and an x. You get x to the 4. The 375, well, I'm actually kind of a big fan here of figuring that out on the side as well. I know 25 goes in there. It has to, because there was a 5 in each of these, wasn't there? And you know what I can actually do? And I don't know how many of you will get this right out of the gate, but I know the other number is 15. Why? Because 75 is 5 times 15. If you need to write this out as 5 times 5 times 5 times 3, which is what 375 is. Am I right there? Yes. Then that's fine. But what we recognize is that a pair of 5s comes out, whether it's from here or here, as a single 5, and we have the square root. What do we have left? 15. Everything else is gone. The x's are gone from the square root sign. We're left with 5 times 8, which is 40, x to the 5, root 15. Questions with that one? Does that look okay? $40. I said 40. My hand was not listening to my brain. 40 x to the 5 square root 15. Any questions with that one? Okay, well, look at the bigger picture here. Don't worry about all the numbers in D. If I gave you x times 2 plus y, and I said simplify, multiply, we know that when you multiply by a binomial or a sum of things, that you have to use what's called the distributive property. You have to take what you're multiplying in and multiply it by each of the pieces. So this would be 2x plus xy. Well, we do the same thing here. You are going to have to multiply. I'm just going to make this a little bigger. You are going to have to multiply this, and you are going to have to multiply this and this. So let's start with 7 root 8 times 6 root 5. 7 times 6 is 42. Root 8 times root 5 is root 40. Your mathematical antenna should be kind of twigging here to the fact that we have root 40, which is going to be simplifiable because 4 divides into it. Then I'm going to multiply the 7 root 8 times the 9 root 20. Let's see, 7 times 9 is 63. And 8 times 20 is root 160. And now we're ready to simplify it. So we'll double check here. 7 times 6 is 42. 8 times 5 is 40. 7 times 9 is 63. 8 times 20 is 160. Okay, so what would we write here? We would write 42 root 4 root 10. I am not, for something as simple as root 40, going to write it as root 2 times 2 times 2 times 5. I'm not going to do that. Even for something like 160, and I'm going to drop the colors here. Man, I'm 16. I can see it right there. I can see 16. There's my perfect square. So I can write it as root 16 root 10. I really hope you guys recognize the significance of the fact that this is root 10 and this is root 10. It means we're going to be able to add those terms together. Root 4 is 2. Root 16 is 4. 42 times 2 is 84. So we get 84 root 10 plus. Am I right that 4 times 63 is 252? Good, thank you. Root 10. 84 kittens plus 252 kittens is 336. We're not adding kittens, we're adding root 10, so 336 root 10. I would, again, caution you in going from this step directly to this step. I know that many of you will and will want to, because you'll just say, well, 42 times 2 is 84. But be careful. Make sure you take the square root of the 4 there. All right, let's try another one. Oh, man. Well, let's FOIL it. What we have is this situation. Right? We've got a binomial times a binomial, which means we are going to have to take the 8 root 2 and multiply by the 9 root 5 first. We are going to have to take the 8 root 2 and multiply by the 6 root 10 outer. We are going to have to take the negative 5 and the 9 root 5 and multiply them inner. And we are going to have to take the negative 5 and the 6 root 10 and multiply them outer. When you start drawing all of those arrows and arcs, it becomes confusing, which is why we rely on FOIL. 8 root 2 times 9 root 5 is 72 root 10. I multiplied 8 times 9 to get 72, root 2 times root 5 to get 10. Outer will be 48 root 20, because 8 times 6 is 48, and the root 2 times the root 10 is root 20. Inner, there's no radical with the negative 5. That's okay. Negative 5 times 9 is negative 45, and then we just have a root 5. And then last will be negative 5 times 6, which is negative 30, root 10. And we have to simplify things here. I know that you know the first and the last items in the list can be brought together because they're both root 10s. I'm just going to leave that alone for the time being and figure out what root 20 simplifies to. Well, 20 is divisible by 4, which is a perfect square. root 4 is 2, which means 48 root 20 is 96 root 5. Well, now let's put everything together. And I don't really think you need to write everything else over and over and over again as you figure this out. Now you can say 72 root 10 minus 30 root 10 is 42 root 10. 96 root 5 minus 45 root 5 is 51. How did I do on that? 51 root 5. And that's the answer. By the way, I'm looking right now at the 5 under the radical. I'm looking at the 10 under the radical. And that's a good feeling because 10 and 5 cannot be simplified further. If I saw 20 again, then I would have to do something with it. Well, now it's cube root. That's okay. Are the indices? Indices is plural of index. Are the indexes the same? Yes. So I can multiply the two radicands. I can write cube root of, let's see, 4 times 16 is 64. D to the 5 times D to the 5 is D to the 10. We add the exponents. Can I simplify this? Well, let's look at not the coefficient. Let's look at the number 64 in the radicand. Can you simplify the cube root of 64? It's 4, isn't it? I mean, it's just 4 times 4 times 4 is 64. If you have to, if you tore 64 down, and in fact, I think we did this one already today, didn't we, with 64? You would have 6 2's. So you can take out a triple and a triple. You can take out a 2 and another 2, which is 4. I'm just curious. How many of you see that that's what's going to happen to the D's? Because D to the 10, and you know, if you have to write this all out, it's a royal pain in the keister. If you have to write it out, I don't know if you notice how I just wrote that. I kind of wrote it in groups of 3. Here's a group of 3. Here's a group of 3. Here's a group of 3. And then this guy, leftover guy, he's got nobody to hang around with. What I'm doing is I'm looking at the number 10 and I'm saying 10 divided by 3 gives me 3. So I'm going to have a cubed outside because I have 3 groups of 3. And I have a remainder of 1, so I have 1 left over inside. Put it another way, if I were to move this d cubed under the square root sign, I would have to put it 3 times, which would mean I would have to put a d cubed, a d cubed, a d cubed. Yeah. Pardon me? Oh, is it 640? I didn't see the 0 there. Thank you. So, rather than mess this up, okay, what I'm going to do here, thank you, Lynette, I'm going to erase all my scrap work. And I'm going to say that had I been paying closer attention and saw that 0, it would be a different question, but this is what I saw, and if that were the question, this would be the answer, okay? However, since there is an extra factor of 10 there, the actual answer to the question is 4d cubed, cube root. We've got that lone d left over. We would also have a 10. Thank you, Lynette. Sorry about that. Does that make sense? Right. I'm just about done here. I'm not going to do G. This is going to be one of the ones where there will probably be something like the question Kendra asked about that you're going to have to try on your own. You would have to multiply this and this and this and this, simplify everything and see if you get like terms. And when you take a look at this one, I'm not going to do this, not because I've run out of steam, but because I think you need time to practice the basics rather than this. But what you would have to do is this. You'd have to multiply 5 root 14 times 4 root 7, 5 root 14 times 2 root 6, 5 root 14 times 5, and then you would have to multiply 3 times 4 root 7, or negative 3, negative 3 times 2 root 6, and negative 3 times 5. Just one second. And then you would have 6 terms that you would have to put together. Go ahead, Kendra.
In D, you multiply 7 root 8 by both. Can I simplify the ones in the brackets and add them together first?
Yes. And this is a very weird situation. As long as you follow BEDMAS, like you do brackets before multiplication, or you follow the rules, the order in which you decide to simplify radicals doesn't matter. And I will even go so far as to tell you, you've pointed out that these two can be simplified and added together, right? 7 root 8 can also be simplified. And I just want to ask you, Kendra, to think about this. Do you see that 7 root 8 is 14 root 2? Because root 8 is 2 root 2. And then what Kendra's saying is this is 6 root 5. And if I simplify root 20, it's root 4 root 5. Root 4 is 2. It's 18 root 5. And we can add these together. Now, you won't always be able to add them together because you might get root 5s and root 3s. But even if you do this and you can add them together, you're still going to arrive at the simplified result. So in this case, we've got 14 root 2 times, 108. 6 times 18. 100 and...
It's 6 plus 18.
24 root 5. So what do we get? We get 14 times 24. Man, that better be 336. If it isn't, we've just discovered a hole in the universe. 336 root 2 times root 5 is root 10. And in this case, it's getting us there a lot quicker. It won't always. This is a very strange thing. You'd think that if we can figure out one way that's quicker, it's always going to be quicker. Sometimes isn't. And when we get to dividing, which we'll get to next week, it can get even more complicated. If we go back and take a look at this one, can I simplify root 5x to the 5 first? Okay, I'm not going to write this out, but x to the 5 is 5x's. I can take out a pair of them and another pair of them. I can take out an x squared and be left with a single x. So that is 2x cubed root 5x. What can I do with this root 75? Well, that's root 25, root 3, root x squared, root x, if I tear it down. So I can take out the 5 and multiply by 4 and get a coefficient of 20. And then I have an x here, and then I have a root 3x, and we're multiplying. So now I can multiply 20x by 2x squared and get 40x to the 4 root 15x squared. Don't leave me yet. I'm not done. Don't fall asleep on me. And I can take out the x squared and add another x to it and get 40x to the 5 root 15. I don't know which one was quicker there. I think this was more work simplifying each first. It's kind of like flipping a coin sometimes. But yeah, you can feel free to do that. Okay. Practice problems. What can you practice? Well, there's lots of stuff in your textbook, page 289, 1 to 5. A little bit later, maybe at about 5 or 10 after, I'll hand back your exams so you can take a quick peek at them. If you are looking at a rewrite for this last exam, please fire off an email to me over the next few days before next week and let me know, and then we can work something out. So get started on that, please. I'm just going to do a couple things at my computer quickly, and then I'll be out there to help you.